Hi there everybody, so we're going to look at exact trig ratios or exact trig values, alright? So I'm going to walk you through how I suppose the exam board would hope that you remember these or learn these, but of course there are some fantastic tricks and ways of trying to retaining it online, which I would really kind of urge you to kind of look at, certainly short term wise, if you're trying to help you to remember it. Now if you're thinking A level further down the line, then you're probably worthwhile learning how I've kind of come across these and actually paying attention to this particular lesson. All right. So anyway, so in terms of an equilateral triangle with side length 2, we can work out the value of sine, cos, and tan for 30 and 60 degrees. All right. And I'll walk you through in terms of why we do this and when we do this. But if you're thinking about a 60-degree angle, then obviously an equilateral triangle is going to provide you with a 60-degree angle. All right. So here we go. So we start off with this, and the reason we start off with side length of 2, and you don't have to, you can choose any side length, but it needs to be an equilateral triangle. But the reason you've chosen 2 is because it's the smallest value that's really going to work. Because what we're going to do, we're going to chop it in half, all right? And because we chop it in half, that's going to change the dimensions of some of these sides, okay? So by chopping in half, obviously you're going to chop that 2 into 1, all right? And any other number to deal with, bigger would be okay, but of course you want to kind of keep it as small as possible and as easy as possible. So when I chop it in half, right down the middle, what happens is I get a 30-degree angle here, a 60-degree angle which is there, this remained as 2, and I've got a 1 here. Okay, so that's the first thing you're going to do. All right. So the height of the triangle, I'm assuming that means this one. I'm going to use a bit of Pythagoras on. So it's going to be 2 squared minus 1 squared, because this is the long one, which is going to give me the square root of 3. I'm going to write that then on there. All right, so I now have this little triangle, which is a right angle triangle, which should support me in working out sine, cos, and tan for these 2 angles. All right, so using my skills of trigonometry and my familiarity with opposites, adjacent, hypotenuse, and all those things, and if you are not, then of course, please go back to look at trigonometry before looking at this one any further. So sine 60, so let's have a look. Sine 60 is opposite of hypotenuse. So if I'm looking at the 60 here, and opposite is this one, and hypotenuse is this one. So it's going to be root 3 over 2. All right, so that's sine 60. If I'm looking at cos 60, so still this angle, cos is adjacent over hypotenuse. So that's going to be 1 over 2. So it's going to be a half. All right, tan 60, well, this is 60. It's going to be opposite over adjacent, opposite over adjacent, so it's going to be root 3 over 1, which is just root 3. All right, so that's 60. Repeat the process for 30, so we're going to look at 30 now. So sine 30, so the opposite is 1, and the hypotenuse is 2, so a half. All right, so sine 30 is a half. Cos 60, well, it's going to be, that's the adjacent, so root 3 over 2. There you go, that's it, cos 30, and tan 30, I should say. Tan 30 is going to be opposite over adjacent, so it'd be 1 over root 3, which is given. But if you rationalise it, and again, if you've not done rationalising, then please look at the lesson on rationalising. Then when I times top and bottom by root 3, I get root 3 over 3. All right, and of course, that's what your calculator will do. So these answers I've got on the end here, this is what your calculator answers would give you. All right, so that's exact values for 30 and 60 degrees. Okay, we're now going to look at exact values for 45 degrees. So in terms of a 45-degree triangle, we're going to use an isosceles triangle with a unit length of 1. All right, and again, I've mentioned before about not necessarily needing to be 1, but certainly, obviously, the smaller value is going to help you an awful lot more. All right, so we've got a 90-degree angle here, and because these are both the same length, that means it's an isosceles triangle, which means these 2 angles are 45 degrees. All right, so using this triangle, I could need to figure out what the length of this one is. All right, so first of all, that side is 1 squared plus 1 squared square rooted, which is the square root of 2. All right, so I'll put that one on. And now I'm just going to work out all these ones. So I'm going to work out sine, cos, and tan. So if I take this one here, so sine is opposite over hypotenuse, so that's 1 over root 2. But of course, this is, like I mentioned last time, it's been rationalised, so it'll be root 2 over 2. Cos 45 is exactly the same, because the ones are both the same, so that's going to be root 2 over 2. And then the tan 45 is the more interesting one. is because it's going to be opposite over adjacent, which is 1 over 1, which is just 1. Okay. All right, so they are your 30, 60 and 45 degree angles. And of course, I've shown you how to calculate them, but of course, it's your job to actually try to remember them in an exam. And I mentioned obviously previously about being stuff online to help you remember, and of course there is, and a lot of these are kind of awkward to do. They are worth remembering. In terms of the GCSE exam, I think in the last few years, I think I've seen it in every single one of them somewhere along the line. Obviously some harder than others, but certainly you need to learn them. All right, so please do go online, figure out a way to learn them. Please visit maths-school.co.uk. Obviously some questions on there to practice on, but obviously you can come back to this to remind yourself how I got them. All right, thanks for listening.